In this question, we're given 9 different graphs, and we're asked to match each equation with the letter of its corresponding graph. Now the first equation in the graph is y equals sine x. So looking at the graph below, let's find out which one represents y equals sine x. And so the graph of sine is a wave-like function. And so we can first start by finding all the graphs that have a wave-like function, and then we can eliminate from there. And so we can see that graph C and graph D have a wave-like function. Now we need to decide which of these is y equals sine x. Looking at graph D, we can see that this graph is symmetrical about the y-axis. But this isn't the graph of y equals sine x. The graph of y equals sine x isn't symmetrical, but the graph of cos x is. And so graph D isn't what we're looking for. Now graph C crosses the origin, and we can see that it represents a wave-like function that is reminiscent of the graph y equals sine x. And so now we've correctly eliminated that graph C represents the graph y equals sine x. And we can write this in our table below. Now the second equation in our table is y equals x cubed plus 4x. So now let's take a look at which of the graphs below represent a cubic function. We can see that graph f is the only graph out of the 9 examples below that have a cubic shape. And so we don't need to go any further than that. Since graph f is the only cubic graph out of these examples, we can say that the graph of y equals x cubed plus 4x is represented by the graph f. And so we can write this down in our table below. And now the next equation in our table is y equals 2 to the power of x, which means we're looking for an exponential graph. So now looking at the examples below, we can see that graph A and graph I are the 2 examples of exponential graphs out of the 9 graphs we have. So now we need to decide which one represents y equals 2 to the power of x. So if we take a look at graph I, we can see that this is a negative reciprocal graph, but y equals 2 to the power of x should be a positive exponential graph. So now we can eliminate graph I. Now we're left with graph A, which we can confirm is a positive exponential graph, because as each value of y increases, so does each value of x. And so we can now say that graph A represents y equals 2 to the power of x. And we can write this down in our table below. And finally, the last equation in our table is y equals 4 over x, and so this is a reciprocal graph. We need to see which of the examples below represent a reciprocal graph. So now looking at the examples, we can see that graph B and graph H are both examples of reciprocal graphs. But now how can we tell which one is y equals 4 over x? 4 is a positive number, which means that we're looking for a positive reciprocal graph. If we look at graph B, we can see that this is a negative reciprocal graph, which means the equation for graph B would be something like y equals minus a over x, which means that the numerator of graph B must be a negative number. But y equals 4 over x is a positive reciprocal graph, which means we're left with graph H, and we can see that graph H represents a positive reciprocal graph. And so we can now write down that the graph of y equals 4 over x is represented by the graph h, as shown above. And so getting these 4 correct answers will allow us to get the full 3 marks needed for this question.